Hi folks, welcome back. So in this fresh set of video series, we will talk about one of the popular tool called Kustomize. So it's basically a configuration management tool. So in the next set of videos, we will discuss about what is this Kustomize, why do we need this, how it helps, in leveraging the basic skeleton files, whatever we define for a particular microservice and reuse them rather than redefining and restructuring every time for a particular environment, and how it can be easily integrated with the popular CI/CD tools like Argo CD, GitHub Actions, or even any other cloud provided CI/CD tools, all those things. So without wasting the time, let's discuss about some of the brief aspects, basically an introduction to Kustomize. So the question here is, why customize? So let's take a scenario of this particular microservice. So let's assume you have a microservice sample where you have already come up with a particular Docker file, and now that you have to deploy it to a particular environment, you have come up with a Kubernetes deployment definition for that, and then the corresponding service, and it requires some of the config maps. So all those things you have defined now. So now this particular microservice has to be initially deployed to dev based on how it goes, subjected to any sort of an increment in terms of fixing the bugs and all those things. Then it is expected to be deployed on QA. So based on how it goes in QA, based on all those sort of tests, then finally it will be eventually, it will go to production. So to deploy it in dev, dev requires its own sort of changes. So dev, requires the deployment name should be in a format like the it's like, for example, the dev hyphen app. So let's assume in the main the deployment file which you have prepared. So you have prepared it as sample hyphen app. Whereas when you deploy it to a particular environment, you want to change it to dev hyphen sample hyphen app, and also the number of replicas. When you initially designed the deployment skeleton, you have mentioned as one, but when you are deploying it to dev, you are expected to change it to two, and some sort of other tags, and changing the resource structure of CPU, memory, and all those things. So in general, you are expected to rewrite the separate deployment file, separate service file, and config file for all those things. Similarly, when you do for QA, again you have to come up with a new set of definitions, the updated definition for deployment, service, and config, same for production as well. So it's a repetitive task. So can we avoid this? Yes. Now the question is the customization subject is supposed to do that? Yes, this is what the customization will do for you. And is the next question is the customization is the only tool does this? No, you can do it in different ways using different sort of techniques, CI/CD techniques. Let's assume you are using GitHub Actions, so you can define all these deployments in the form of an Helm chart, and you can come up with a different value files for dev, QA, and production, and with some sort of customization there, you can reuse the same skeleton structure. Similarly, any other cloud provided CI/CD tools, or the another popular choice of tool called Argo CD, it almost does the same thing. But what is that extra thing which customization bringing it to the table? So what is the X factor? So this is the X factor. For example, so let's do one thing. What we will do is we will keep all these core deployment definition, whatever initially you have written, the deployment.yaml, service.yaml, config.yaml, in a particular folder called base. And then we will write this special configuration file called customize.yaml, inside which you are going to define what are all the files which are subjected for customization. In this case, the deployment.yaml, service.yaml, and config.yaml are subjected to customization in development environment, QA environment, and production environment. That means the definition, whatever you are writing initially for deployment, service, and config, is going to remain as it is in the base. Whereas in dev, QA, and prod, when you deploy it, you are going to add some kind of modification. So that when you say modification, for example, in the original base deployment.yaml, you may have replicas as one, you are going to change it to two, and you are going to append the deployment name with dev hyphen, and you are changing the CPU and memory resource, something like that. These are all the customizations which you are going to define inside a customization.yaml file with the help of a file called patch.yaml, which we shortly going to touch base what are the different sort of patching techniques, all those things and all. So ideally, there are two type of patchings which customization has allowed. The JSON sort of an patching and then the strategic merge patching. Nowadays, with latest version and all, both can be leveraged with just one command called patches. So when initially customization was launched, you are defining these two in a separated manner. Still, those things are start supporting with some kind of an warning like it will be deprecated soon and all those things. So it is still working. So now what we are doing in this kind of section to use it separately in dev QA and prod is we have come up with a separate folder called overlays. There in suppose this particular microservice subjected to deploy initially dev QA and prod, so we'll create three different folders inside a overlay folder. One is dev, another is QA and prod. There we will define this special file called customization.yaml. So, you may ask, then why I have defined this deployment.yaml, service.yaml, and config.yaml here? This is just for, initial demonstration purpose for you that this is how earlier it used to be done, and now we can replace it with just patch.yaml. So now, these three files will go away, and then there is only one file which is patch.yaml inside which I'm going to define for a customization that what are the patching I'm doing. In this case, I'm doing patching for a deployment where increasing the number of replicas from 2 to 5 or 1 to 3, something like that, and increasing the CPU resource, and maybe changing the value for a particular config map, for example. So let's assume, or one more, this is one scenario. One more scenario why I have put these three files here is, so let's assume that in the original config.yaml, you might have added only one config map entry. So now when I deploy it for dev, I may supposed to add one more config map entry that you can define inside this config.yaml and apply it as a patch for the customization.yaml. That's the another sort of an usage. So basically, all these things can be leveraged through Kustomize. So let's go and see a simple example here. So this is the typical directory structure. This is how you should define it. So let's assume my app is your microservice. You are going to create a directory called base, and here you are defining your microservice definitions. So in this case, I am defining the definition for deployment.yaml and then service.yaml and then the special file called customization.yaml. That is where I am subjecting these two for customization through this syntax. So if you see here, resource deployment.yaml and service.yaml, this shows that the deployment.yaml and resource.yaml is subjected for customization in in the environments whatever you defined inside a overlays. So now and also you are applying something called as a common labels like app.myapp, that which indicates that these labels will be applicable to all the environments. When I say all the environments, whatever the environments you define inside overlays. So now, if you come to overlay dev, so here again I'm writing a customization.yaml. So in the resource section, I'm taking all the base. That means automatically all the files which are available in base, you are automatically referring using this. Plus, I'm adding a patch.yaml. I was just mentioning in the previous slide that there are two type of patching techniques, which is like JSON patch and then strategic merge. With the latest kind of an syntax, you need not to mention this entire thing. However, still this will work with some kind of an warning. So in the patch.yaml, what I'm doing is I'm doing a patching for the deployment definition. That means I'm not rewriting the entire deployment.yaml separately for dev. Rather than I'm using the deployment definition which is mentioned in the base. On top of that, I'm just adding some of the customization for that. In this case, I'm increasing the number of replica from 1 to 2. That's all, that's simple. It's like straightforward approach. Similarly, in the production, let's assume that you want to increase the resources, like CPU and memory. You can do that by defining the customization .yaml and patch.yaml separately there. Same thing. It works in a similar manner. So now let's go back and see the simple architecture diagram for this. So in a typical organization, usually, the files will be, all the deployment definition files will be kept in one of the code repository. In this example, I'm using a GitHub. That's one of the popular choice of tool. So we have kept the deployment definitions here inside the GitHub. These deployment definitions are in the form of an YAML, and also, it's your source of truth is not just a GitHub. You can even, reference to the Helm charts, the remote Helm charts, whatever it is, put it in a particular GitHub repository or some local other, public maintained repositories. So either, there are two ways where you can consume the Helm. Either you can generate a Helm template out of the, this Helm chart, and although, like for example, let's assume you take a Helm chart of Grafana. So when you generate a Helm template for that, all those Kubernetes custom resource definitions, and then the secrets, configs, deployment state, file stateful sets, whatever it is, all those things you can keep it in a particular folder as a base, and then you can override it with overlays for a particular environment as well. So either you can generate, that is the reason why I given two arrow marks here. So you can either generate the YAML files out of this Helm as a template, or directly you can reference the Helm chat and you can customize it. So for example, if I've defined, Grafana chat directly from the public repository, Grafana official repository. So let's assume the chat name is Grafana. When I deploy it to dev, I can change it to dev-grafana. Similarly, when I deploy it to QA environment, I can change it to what do you call, QA-hyphen Grafana. Similarly, the values, for example, here that password which is required for dev environment might be something, and I can change the admin password separately for QA, separately for prod. All those things, you can do. It's a very straightforward thing. That's the simple explanation about the architecture. So I've already given an explanation about this simple example. So the same thing I put it in a slide. So in this slide you can see what is this customize, why do we need this customize, and what are the challenge it is going to solve. So as I mentioned, Kustomize is just a tool, which manages the Kubernetes YAML configuration. That means typically you are defining everything as a YAML, which basically, the beauty of this Kustomize is reusability. You are defining a set of YAMLs at one place, and you are utilizing it at multiple places. And the another beauty of this is what do you call, the reusability of the code. That means the code which is written at one place can be used for multiple environments without affecting the structure of the original by overriding some of the stuffs whatever it is there in the original. That's the beauty. And it's straightforward declarative configuration management tool where everything is declared sufficient, manner it properly. And another beauty is it is natively support with heavily supported with kubectl commands. That means, for example, you can, if you want to deploy something directly, you can use kubectl apply with hyphen option k, that directly, all those customization YAMLs whatever written, that's going to deploy. Or you can use kubectl customize build or customize build, something like that. It's tightly integrated, and it comes with Kubernetes kubectl package client directly from the 1.14 onwards. It is available in that ecosystem from 1.14 minor version onwards. So that's about at the high level introduction for this. Now some of the key features which we already discussed, that there is no separate template required for this. Everything can be leveraged through a straightforward YAML sort of an format and reuse it for multiple places, and it's a very declarative kind of an approach. And it has a built-in support for kubectl. And the patches also we discussed, like there are two types of patches and how we can deploy that. And don't worry about the way to deploy the patches and all, which we are going to discuss in detail with sufficient number of examples in the upcoming videos. And how customization work also, I think we have already touched based on this, that we have something called as an basis and then something called as an overlays, where that whatever you define inside a base can be overridden, or it can be customized in the environment specific to overlay. The another key concepts about customization is something called as generators and transforms. So let's imagine a situation. Let's come back to this previous slide. So let's imagine a situation that you, rather than defining the config.yaml. So what if, like, I don't want to define in separate YAML, and I want to give it on dynamically inside the customization.yaml to generate the config map when it deploys by supplying the literals, whatever it is required for config map. Similarly, for secrets as well, I want to, dynamically, let's assume that you are using a GitHub and you have stored some sort of a secrets inside your GitHub secrets. Uh, you know, Action secret repo, GitHub repo, you have stored some sort of a secret, could be an environment level or organization repo level. You have stored some sort of an secrets, and dynamically you are updating during a deployment using some sort of an updating mechanism or custom scripts. So at that time, you don't want to define separately as a config.yaml, rather than let it generate the config and secret configs, and secrets dynamically through customization.yaml. Those sort of an approach can also be handled using customization. So in that case, you will be defining these transformers using config map generator and secret generator that will dynamically generate the secrets and deploy to a particular environment. Again, those secrets as well can be overridden. For example, in the config map generator and secret generator, you might have defined one secret, and here you can override it with two secrets, or you can not even deploy that source secrets as well. It's up to you. I mean, like, those kind of customization is also possible. So don't worry, again, config map generator, secret generator, all those transformers individually, we will look into it to, with sufficient number of examples and understand fully. We also have some built-in transforms, like for example, if you define a particular label at base, that how those labels can be, transferred to all the overlay deployments for different environments, and this how to override these labels as well. And also, I have told about, like for example, in a base you have defined as sample hyphen deployment, whereas when you deploy it for dev, it should be like dev hyphen sample deployment. Similarly for QA hyphen sample deployment. Even those can be done with the help of an predefined prefix labels and suffix labels. All those kind of built-in functions are available. There are some other built-in functions like multibases, multiple objects reference. When I say multiple objects reference, it could be not just deployment, it could be a config map, it could be secret, multiple objects, basically. So, all these sort of different examples, in detail, we will understand one by one practically. Then I think you will get more sort of in clarification when we do in live. So, some of the benefits, again, the same thing. It's environment specific configurations we can maintain, and there is no destructive because original YAML will be always present inside your base. And simplified because, here the beauty is one person is, or one team is going to manage the base files, and all other members will just reference and override or customize as per their requirements. So that's the introduction to Kustomize at the high level. So we are going to touch base in detail about individual features of this Kustomize with sufficient number of examples, around I think 9 to 10 examples I have created. So in the upcoming videos we will go through those in detail and try to understand all those aspects in detail. So I'll see you guys on the next set of videos. Thanks for watching this. Please do subscribe to my channel and support me. See you on next video.